we will be discussing about Mathematics Paper 4, Mechanics M1, 2017, May-June, variant is 41 and the subject code is 9709. Number 1, a particle of mass 0.6 kg, so 0.6 is dropped from a height 8 meter above the ground. So the particle is dropped from a height 8 meter. The speed of the particle at the instant before hitting the ground is 10 meter per second. So before hitting the ground it has a speed of 10 meter per second. Find the work done against resistance. So we need to find work done against resistance. So we know the values of speed and we know the height. So since we know the speed, we can calculate the kinetic energy. Then we know the values of height, that is 8 meter. So we can easily calculate the gravitational potential energy. So we can use the energy method to solve this. That is, gravitational potential energy at the top is equal to kinetic energy at the bottom plus work done at the bottom. And at the top, since the particle is dropped and there is no information about the speed, that means at the top of the plane it has a speed 0, so kinetic energy is equal to 0. That means initially it has only gravitational potential energy, and before it reaches the ground it has kinetic energy and work done against resistance. So gravitational potential energy is equal to kinetic energy plus work done against resistance. So we equate this to find the work done against resistance, that is 18 joules. Number 2, a particle of mass 0.8 kg is projected with a speed of 12 meter per second. So initially the particle has a speed of 12 meter per second up a line of the greatest slope of a rough plane. So the plane is rough, that means there is an effect of friction, that is mu r. And since the particle is moving upward, so the friction would act downwards, that is downward. And the plane is inclined at an angle of 10 degree to the horizontal, so 10 degree. The coefficient of friction between the particle and the plane is 0.4. So the coefficient of friction, that means we have given the value of mu. We need to find acceleration of the particle. To find the acceleration, we know the downward component of weight, that is 0.8 g sine 10, and we know the friction, that is mu r, and there is no forward forces acting, so forward force is 0, so forward force, that is 0, minus backward force, that is mu r, minus 1.8 g 0.8 g sine 10 is equal to mass into acceleration. So we equate this to find the value of acceleration, that is negative 5.675. Since the value is negative, so it is deceleration, and acceleration value is negative value, so negative 5.68 correct to 3 significant figures. Find the distance the particle moves up the plane before coming to rest. So before coming to rest, that means before coming to a speed that is 0, what distance the particle travels. So to find the value of distance, we know the final speed, that is 0. So final speed is 0. We know the initial speed, that is 12 meter per second. So v square minus u square is equal to 2as, and we need to find the distance, that is s, and we have initially found acceleration as negative 5.68. So we need to just substitute the values to find the distance, that is 12.7 meter correct to 3 significant figures. Question number 3. So we have given the diagram, and for this diagram we have given that the system is in equilibrium. Since the system is in equilibrium, that means the resultant force is 0, that means the system is at rest. So we need to find the value of A and B. To find the value of A and B, we know that since there is no friction or no other forces acting and it is the same string, and so the tension in this part is same as the tension in this part, and also the tension at this part is same as the tension at this part, and the tension force always act in the opposite direction to the object. Since if suppose it is the object, so it acts opposite direction to the object and towards the pulley. Similarly, it acts opposite to this object and towards the pulley, so tension actually acts towards the pulley. Then we know that this value of tension is same as this value of tension, and if we just draw this diagram, then we need to find the horizontal and the vertical component of this tension, that is this side. Then for TB, we need to draw its horizontal and the vertical component of forces of the tension. Then we know that the downward force is 25 Newton. So since the system is at rest, So downward force is equal, since the system is at equilibrium, that means it is at rest, and since it is at rest, so downward force is equal to upward force, that is TB cos 40 plus TA cos 30 is equal to 25 Newton. So we equate this, and it is our first equation. Then what would be the second equation? We know that TA sin 30 and TB sin 30, and there is no additional forces acting, so that means this force is same as this force, so we equate this to find the second equation. Then we just substitute the value of TA in the equation to find the value of TB. Then we substitute the value of TB in this equation to find the value of TA. That means it is just a simultaneous equation, and we found the value of TA and TB. So TA is the tension A or the force A, and TB is the tension B or the force B. So this is the answer. In question number 4, so a car of mass 800 kg is moving up a hill. So since it is moving up a hill, that means it is moving up a slope, and here is our car. We have given its mass, so this is the weight, that is 800 g, where g is the gravitational field strength, and the hill is inclined at an angle theta, that is theta, to the horizontal, where we have given the value of sin theta. The initial speed of the car is 8 meter per second. That means at the bottom of the hill it has a speed of 8 meter per second. Then 12 seconds later the car has traveled 120 meter, that means 120 meter up the hill, and has a speed of 40 meter per second. So 12 seconds later, that means suppose at this point we consider this at y, so at this point it has a speed of 14 meter per second. Now find the change in kinetic energy. So change in kinetic energy is equal to half into mass into speed square, that is final speed square minus initial speed square. So this is a change in kinetic energy, and these are the values of speed. Then change in gravitational potential energy. So we know that gravitational potential energy is mass into gravitational field strength into vertical height. So what is the value of vertical height? We know that the particle has traveled 120 meter, that means we have given the height of the height, that is, or the slope of the height is 120 meter, so we know this side, and we know the value of angle, so we need to find the h or the vertical height. So we know that sin theta is equal to opposite by hypotenuse, so opposite, that means height would be sin theta into hypotenuse. And what is the value of sin theta? Sin theta is equal to 0.15 that we have given, so we know the value of vertical height, so we can easily calculate the gravitational potential energy, that comes to be 144,000 joules. In part 2, the engine of the car is working at a constant rate, so given the value of power, find the work done against resistance. So we need to find work done against resistive force during the 12 second. So for the 12 second we need to find work done against resistive force. So this is the initial diagram, and from this diagram, to find the work done against resistive force, we initially know the kinetic energy, change in kinetic energy, and change in gravitational potential energy. So we can use the energy method to find the work done against resistance. So at the bottom of the slope, that means at point x, and the top of the slope at point y. So initially it has a speed of 8 meter per second, that means it has kinetic energy, and initially we have given the value of power, that means it has some driving force. So work done by driving force, so initial kinetic energy plus initial work done by driving force is equal to, we need to find the work done by resistive force, that is the final work done against resistive force, is equal to, as it moves up the hill, so it has some gravitational potential energy, and we know that it has some speed, so it has kinetic energy. So we equate these values to, okay, so what is work done by driving force? So we know that work done is equal to power is equal to work done by time, or work done is equal to power into time. So we know the value of power, and we know the time, that is 12 seconds. So we have found the work done by driving force is equal to change in kinetic energy plus change in gravitational potential energy. From this part, change in kinetic energy plus change in gravitational potential energy is plus work done against resistive force. So the work done against resistive force comes to be 187,200 joules. A particle P moves in a straight line ABCD with constant deceleration. So the deceleration value is constant, and we take the constant deceleration as A. So we assume that the constant deceleration is A. The velocities of P at A, B and C are given. So at point A, B, C and D. So this is the total distance, and for A, B and C we have given the velocities. Find the ratio of distance AB is to BC. So to find the value of ratio of distance, we need to first find the distance AB. So what is the distance AB? So we know the speed at A, we know the speed at B. So we can use v square minus u square is equal to 2as, where we know the final speed, that is the speed at B. We know the initial speed, that is the speed at A, is equal to 2as, where A is the constant deceleration and S we need to find. So we get the value of S from AB. Then to find the ratio, we need to find the distance BC. So to find the distance BC, again we know the final speed at C, we know the initial speed at B is equal to 2as, where A is the constant deceleration. So S, that is the distance BC, we know that. So to find the ratio, the distance AB is to BC, that is AB divided by BC. So after dividing this and solving this equation, we get the ratio as 64/27 or 64:27 as the final answer, that is the ratio of AB is to BC. Part 2. The particle comes to rest at D. As it comes to rest, that means at rest velocity is 0. So at point D, the velocity is 0. Given that the distance AD is 80 meter, so the distance from A to D is 80 meter. Find the distance BC. So to find the distance BC, we know the equation v square minus u square is equal to 2as, where we know the final speed at C, initial speed at B, and to find the distance we need to find the constant deceleration, that is A. That is earlier given that a constant deceleration A. And to find the value of this constant deceleration, we know the distance AD. So we know the distance AD, we know the speed at D and speed at A. So we just substitute the values in v square minus u square is equal to 2as to find the acceleration. And since it is mentioned that it is constant deceleration, so the acceleration value is negative, so deceleration would be positive. So this is the acceleration. So we have given the value of acceleration, so we substitute the values in the equation to find the distance BC as 21.6 meter. The distance between BC is now 21.6 meter as the answer. In question number 6, part 1, show that when time t is equal to 0.5, the acceleration is this value. So we need to basically find the value of acceleration. And to find the acceleration, we have given the expression for velocity, but to find the acceleration, first of all we need to find the constant q and r. So to find the value of constant q and r, we know the value of velocity and the values of time. So we just substitute these values in the equation of velocity. This is when time t is equal to 1, velocity is equal to 4. We substitute these values in the expression for velocity to find our first expression. Then when time t is equal to 2 and velocity 4, we substitute this in the equation for velocity to find the second expression. Then we just solve it simultaneously to find the value of r, that is -2, and the value of q, that is 6. So we just substitute the values in the expression for velocity to find the equation for velocity. And we know the expression for velocity. So what is acceleration? We need to differentiate velocity with respect to time. So dv by dt, that is differentiating velocity. So 6t would become t, then minus 2t square, so 4t. So this is the acceleration expression. Then we need to substitute the value of time in this expression to find the acceleration. Then in part 2, find the time when p is at instantaneous rest. So at instantaneous rest, we know that velocity is 0. So for the expression of velocity, we have to equate it to 0 to find the value of t. And you must notice that we need to find values of t. So to find the values of t, that means multiple values of t. So the first value would be t is equal to 0 and the second value is 3. Part 3, the particle is at O when time t is equal to 3. That means when time t is equal to 3, the particle is at O, that means the distance is 0. Since the particle starts from O, that is the particle passes through O or starts from O, so as it starts from O, that means its original position, and when time t is equal to 3, it returns to its original position. That means distance is 0 or the displacement is 0. That means if it starts from its original position at O, then again it returns to O. That means now its displacement is 0. So at time t is equal to 3, the displacement is 0, and find the distance of P from O when time t is equal to 0. To find the value of distance, first of all we know the expression for velocity, then we need to integrate this to find the expression for distance. So this is the expression for distance, but since we have to integrate this, we get a constant c, and to find the value of constant c we have to substitute time t is equal to 3 at s is equal to 0. So we substitute these values to find the value of c. Now we know the expression for displacement, and to find the value of distance at time t is equal to 0, we need to just substitute the value of time in this expression to find the distance as -9. So this -9 is actually displacement. So what is the distance? Distance is +9 meter. Question number 7. Given that both the planes are smooth, find the acceleration of A and the tension in the string. So we need to find acceleration and the tension. So, and here the informations that were given are basically given in the diagram, so we do not need to read this right now. And the particles just start from rest, so initially its speed is 0 or it is at rest. So basically we need to find acceleration and the tension. So we have given the mass of A and its weight is 0.8 g, and for its weight we need to find its horizontal and the vertical component of weight. Then for particle B we need to find its horizontal and the vertical component of weight. And as we know that if we compare these two values, then we can see that the weight of B is more and the angle is also more, so B would move downward and A would move upward. So since B is moving downward, so forward force, that is 1.2 g sin 60, minus backward force, that is the tension, is equal to mass into acceleration. Also for particle A, the forward force, since the particle A is moving upward, so the forward force is tension, so tension minus backward force, that is 0.8 g sin 30, is equal to mass into acceleration. So the second expression, that is the first expression for B and the second expression for A. So we equate the two values of tension. Now we just need to solve it simultaneously. So we equate the two values of tension to find the acceleration as 3.20 meter per second square. Then we need to substitute the value of acceleration in any of this equation to find the tension as 6.56 Newton. 7 part 2. It is given that instead both the planes are rough. Now both the planes are rough, but initially we have given that both the planes are smooth, but now it is rough. So for the planes that are rough with the same coefficient of friction, that is mu, that is for both particle A and B the coefficient of friction is mu. Then for both the particle, find the value of mu. So we need to find the value of mu for which the system is at limiting equilibrium. Equilibrium means that the system is at rest, but limiting equilibrium means that as the system is at rest but there is an effect of friction, that is mu r. So equilibrium means that the system is at rest, but limiting equilibrium means that the system is at rest but frictional force is acting. So in limiting equilibrium, frictional force is acting but the system is at rest. So since the system is at rest, so forward force is equal to backward force, or for particle B and A and B we need to find the forces. So now we know the downward component of weight, and since initially the particle is smooth, that means tension has some other values, but now as the plane is rough, that means we cannot use the initial values of tension and acceleration because these values are when the surface is smooth. But now the surface is rough, so we cannot use these values. So that means our tension is T and T. So the downward force we have given the value of T, and since though the system is in limiting equilibrium, but the system tends to move downward since the weight of B is greater, or the system moves in such a way that B moves down and A moves up. But though the particle is at rest or the system is at rest, but if they move, they tend to move in this way. So we know the downward weight and the upward tension, that is T, and since the B is moving downward, so the friction would at upward. As B is moving downward, so friction would at upward, so friction is mu r, and for A is moving upward, the friction would at downward, that is mu r. So for particle A, the forward force is tension is equal to backward force, that is mu r, and 0.8 g sin 30. So for particle A, the forward force is tension and the backward force is mu r minus 0.8 g sin 30 is equal to mass into acceleration, and acceleration is 0. So the system is at rest. And what is the value of r? As this force is acting downward, so r is the normal reaction force that is acting upward. So as there are no forces acting, so r is equal to this force, that is 0.8 g cos 30, that is the vertical component of weight. So r is 0.8 g cos 30 and mu, so this is mu r. So this is the first expression for A, and for the expression for B, so r is equal to 1.2 g cos 60. So r is equal to 1.2 g cos 60, that is 1.2 g cos 60 into mu, that is mu r. And since B is moving downward, so downward component of weight minus tension minus mu r is equal to mass into acceleration, that is the forward force minus backward force is equal to mass into acceleration. And since the system is at equilibrium, so acceleration is 0. So this is the second expression for B. Now we need to just solve this equation simultaneously to find the value of mu, that is 0.494 as the final answer. And since mu has no unit, so this is the answer.